Hello. In this unit, we are going to be going through gas laws. In order to do that effectively, we need to make sure that we know what the different variables are, how we talk about gases, and what unique properties gas have that allow us to investigate these different relationships. I have a small picture of three different primary states of matter on the bottom of this slide, and we can see that the difference between gas, liquid, and solid, but why gas is different from the other two, is its compressibility. In kinetic theory, we have talked about the idea that there's space between gas molecules. So they can kind of move away from each other to fill up a larger space, or they can be compressed to take up a smaller area, but it's really the space between the particles that is changing, not the size of the particles. At standard temperature and pressure, the distance between the gas particles is, on average, about 10 times the size of the molecule. So, when we draw gas particles in a container, we are usually not drawing them with the actual distance between the particles on average. We kind of accommodate for that so we don't have to draw such large containers. There are four variables that we will use to describe gas, and you should be familiar with all four of them, though I will talk about each of them in a little bit of detail to make sure that we are all on the same page of understanding. Pressure is the first, and we measure that in the SI unit of kilopascal. Volume, we measure that in liters. Temperature is measured in Kelvin, and then amount of gas is represented by N, and that can mean number of moles. It can also mean number of molecules, but when we're actually going through the mathematical calculations, we will be talking about moles. So we're going to discuss pressure first. Pressure is a force exerted over a unit area. And with a gas, that pressure is created by gas particles colliding with the walls of a container and with each other. So it's actually the individual gas particles colliding with the walls of a container that create this force over an area. To give a little context for talking about each of these variables, we're going to use kinetic theory to discuss how pressure changes when the other three variables we're about to talk about change or are affected. Volume is measured in liters, and this is the volume of the container, whatever's holding the gas. This could be a balloon, this could be a eudiometer, which is a gas measuring device used in lab, or it could even be the room that we're talking about. Remember, gas will take the shape and volume of its container, and that's the volume that we'll need to discuss. So how does changing volume affect pressure? If you look at this diagram, you can see the same number of gas particles. On the left-hand side, there is more space between them in the larger volume, so they have room to spread out. When the volume is smaller, they all get compressed into this little area. There are more collisions happening on the right-hand side because the particles run into each other and run into the walls of the container more often. Just because there's less space for them to move around, they're going to have more collisions. So, as temperature increases, the pressure increases. As volume decreases, pressure increases. Now we're going to talk about temperature. Temperature is measured in kelvins, and it's very important during the gas laws unit that you use kelvins as your measurement for temperature. Temperature is a measure of average kinetic energy. So, particles with higher energy strike the wall of a container with more energy. That means they're exerting a greater force. Because they have more energy when they collide with the wall, there will be a greater force. So we look at this. How does changing temperature affect pressure? The different sized arrows on these gas particles indicate their velocity, okay, their kinetic energy. On the left-hand side, they are moving more slowly. On the right-hand side, they have longer arrows indicating they are moving with more kinetic energy. Since they will be striking the wall with more energy, it creates more pressure and has a higher pressure when we are at a higher temperature. Finally, gas, the amount of gas, and we're going to talk about this in number of moles as represented by the letter N. Like I said earlier, we can talk about this in terms of moles or molecules, but when we do calculations, we really need to talk about it in terms of number of moles. The best example that I can think of to talk about this one, as we add more gas into a balloon, so as we add a larger number of moles, it's going to increase that pressure, right? There's more collisions because there are more particles. It becomes like a crowded room as opposed to a room that has fewer people in it. And there you can see there's open space because of a fewer number of particles on the top box, number 1. And on the bottom box, there are more particles in there, indicating there'll be more collisions with a greater pressure. Looking forward, we're going to use these 4 variables, and we're going to look at relationships between these variables to talk about the gas laws. There are a distinct set of laws that we will be looking at in terms of gases and seeing how these relationships affect us in our daily lives.